purpose of this video is actually to talk about exponential family of distributions. Okay, you know, another way to figure out sufficient statistic is actually to use, to investigate whether a particular probability distribution belong to the family or exponential distribution. I'm actually going to say exponential families of distribution provide a general framework, for selecting a possible alternative parameterization of a family of distributions. I'm actually going to share my whiteboard now. Okay, I'm going to show you, you know, the formula. Okay, so when we talk about exponential family of distribution, we could talk about one parameter family or multiple parameter family. Of course, we know we got, there are some probability distributions with one parameter. We got some probability distribution with more than one parameter. Okay, so if f of x, okay, given theta, okay, which is a parameter, if it can be written as this, t of x, okay, c of theta, okay, plus g of theta, okay, plus f of x, okay, we actually going to say that particular probability distribution follow exponential family. Okay, and the moment it follow exponential family, when you take a look at the function of x here, that is multiplied by another function of theta, we actually going to say summation of t of x, okay, I start from 1 to n, okay, is a sufficient statistic, okay, a sufficient statistic, okay, a sufficient statistic for theta, okay, and you know what of in a situation, like this is one parameter family, okay, that's a one parameter family. So what if I'm talking about multi-parameter family, okay, maybe I want to talk about multi-parameter, okay, for multi-parameter, okay, maybe I got theta in a parameter space, theta 1 or theta 2, or probably until I get to theta k, okay, my f of s given theta is actually going to be that, and you know what, I'm actually going to have uh, that summation that, okay, I'm actually going to have that, and I is going to start from 1 to k. I'm still going to have d of theta and plus s of x. Okay, so what I'm actually showcasing now is when you have one parameter family and when you got multi-parameter family, okay, the implication of a distribution following exponential family of distribution is that we'll be able to obtain sufficient statistic. Of course, it is not, getting a sufficient statistic is not only using Fisher factorization or using Skefi lemmas. Okay, we can also obtain sufficient statistic if we're able to investigate, whether the distribution under investigation or follow an exponential family of distribution. Okay, so I'm going to stop my share now. So what I'm actually going to do is to walk you through an example of such. Okay, let's say for instance, we got X follow maybe it follow Bernoulli distribution, okay, with parameter 1 and p, okay, and of course, Bernoulli distribution, or given the parameter p now, okay, is actually going to be, it's more or less like I'm writing f of s given theta, Okay, f of s given theta, I'm actually saying might be equal to theta, and the distribution is going to be theta raised to power s 1 minus theta raised to power 1 minus s. Don't forget, Bernoulli distribution take a state space of 0, 1. Okay, so when you take a look at this guy now, okay, I want to investigate whether I follow exponential family. And of course, I'm actually going to do f of s that equal to, don't forget, I said my theta is the same thing as p, so I'm actually going to write ESP, okay, and if I do lean, okay, if I write this as a lean, or natural log of f given theta is the same thing as exponential, the same thing as this guy here. So what the bottom line is, the f of x given theta is actually going to be equal to exponential ln f of x theta. Okay, so what I'm going to do now, so I'm actually going to write this into ln. What is the f of x given theta? That is distribution under investigation. Okay, 1 minus s. Take a look at that. Okay, so when you take a look at this now, all what I just need to do is to simplify. Okay, so gonna have this raised to power x plus ln raised to power minus 1 minus that raised to power this. Okay, so what I'm actually using now is like using the law of logarithm of a product, which is actually going to be the sum. Okay, now I'm going to clean my whiteboard right now because I need need some room. Okay, now if you take a look at what I have right now, okay, now my f of s given theta is actually gonna be equal es of that, then x ln of theta, okay, and 1 minus s, okay, 1 minus s ln into 1 minus theta. Okay, take a look at that. Okay, so when you take a look at what I have now, or what I just need to do is to simplify, right? Actually, I'm gonna simplify. Okay, so I got s ln theta, okay, plus, okay, when I use 1 minus 1 multiplied by that, I'm actually going to get this guy, then minus x ln 1 minus theta. Okay, that's what I'm going to have now. So you can see we actually having algebraic simplification. Okay, I told you the other time, algebra is very, very important. Okay, so I think I need to tidy it up. What I just need to do now is to tidy it up. So I have this guy now. Okay, so when you take a look at what I have here, so it's the same thing as this guy. Okay, plus ln 1 minus theta. Okay, when you take a look at this guy, you can actually rewrite that as x, okay, into ln of theta minus ln into 1 minus theta, okay, plus ln into 1 minus theta. Okay, so when you take a look at this now, I'm actually going to have, using the mathematical law here. So this is going to be theta over that. Oh my God. Then I go 1 minus theta. Take a look at that. Now, this is the final simplification. Okay, so let's see whether this follow exponential family. Okay, so I take a look at that now. That's a function of x, right? And we're taking a look at this guy now. That's another function of s is going to be c of theta. And this is only a function of theta, which is going to be d of theta. Okay, right here now we don't have s of s. Okay, it's imply f of s equal to 0. Okay, so what am I talking about? Okay, since this follow exponential family, okay, then it would be possible to figure out, sufficient statistic. Okay, so because this follow exponential family, so I'm actually going to say my sufficient statistic is actually summation t of s, and the summation t of s in this case now correspond, the t of s is x, right? Which is going to be summation x. Okay, so what am I talking about? What I'm talking about is, for instance, if I using a what I call Bernoulli random process, a random distribution, maybe I actually